Right, so we're going to look at how to graph a trig function. So this is how to graph a trig function by hand. So the first thing you want to do, this is graphing either the sine or cosine. So let me put that up top. So this is for specifically when you have y equals a sine of bx or y equals a cosine of bx, where b is greater than 0. So the first thing you want to do is find the period. And to find the period, you take 2 pi and you divide it by b. Then what you do is you're going to start with 0 on the x-axis and lay off a distance of the period, so 2 pi over b. So I have this problem over here to the right, and so we are going to graph this following these 5 steps. So let's draw ourselves out an xy axis. And here I have y is equal to, so I'm going to put these in here. So y equals a sine of bx. So here we have, now we can match it up. So our a here is -2 and our b is 3. So the first thing I need to do is to find my period. So using this equation, my period would be equal to 2 pi divided by 3. So 2 pi divided by 3, and so I want to lay off a distance on my x-axis from 0 to 2 pi over 3. And then I'm going to take 2 pi over 3. So I'm done with step 1. But now I'm going to divide the interval of the period into 4 equal parts. So in order to do that, what do? I am going to take 2 pi over 3, and I'm going to divide it by 4. Dividing it by 4, remember when we divide fractions, it's the same as multiplying by the reciprocal of the second fraction. So flipping this to 1 over 4, I wrote the whole number of 4 in fraction form as 4 over 1. And now I get 2 pi times 1, or just 2 pi, and then 3 times 4 is 12. And then I can reduce this fraction. This is pi over 6. 2 and 12 have a common factor of 2 that divides out. So that means that I'm going to split this into 4 equal intervals. So I've got 1, 2, 3, 4 equal intervals, and they are pi over 6 apart. So this would be pi over 6. This would be 2 times pi over 6, and this would be 3 times pi over 6. But I can reduce both of these center ones. Both of those fractions reduce. Both of these are divisible by 2, so I would get pi over 3. And both of these are divisible by 3, and I would end up with pi over 2. So I've got my 4 equal intervals, and I have my x-axis marked off. So let's erase that. And so now what's my next step? Evaluate the function for each of the 5 x values. I have 5. 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Resulting from step 2, so that's what I have, the points that you will get will be the maximum points, the minimum points, and the x-intercepts. So I'm going to come over here and I'm going to create myself a table. I'm creating myself an XY table. And I'm going to plug in those 5 points. And so I'm evaluating the sine, I'm sorry, not the sine, the negative 2 times the sine of 3x. So in for x, I am plugging in those values. So when I plug in 0, for x, what do I end up with? I end up with negative 2 times the sine of 0. And at 0, the sine value is the y value, which is 0. So I'm going to say negative 2 times 0, which would give me, give myself some more room, which gives me 0. Now, my xy table is typically just would be 0, 0. However, I do have, I just wanted to write out the steps that I'm doing in between to show you. So the next one, I would have negative 2 sine of 3 times pi over 6. And that would result in negative 2 times the sine of pi over 2 when I reduce this 3 pi over 6. So 3 times pi over 6 gives me pi over 2. And at pi over 2, the sine is 1. So I'm going to have negative 2 times 1, which is negative 2. And then I keep doing that for each of these. So let me put this in. And so I'll get pi over 3. I put pi over 3 in here, pi over 2, and 2 pi over 3. So when I simplify this, I get the negative 2 sine of pi. And at pi, the sine of that is 0. So I'm going to get 0 again. Here, when I reduce, this one doesn't reduce, so it's the sine of 3 pi over 2, which would be negative 1. And negative 1 times negative 2 is a positive 2. And then the last one, I would have, when I reduce this, I get 2 pi. And at 2 pi, the sine is 0, so I'm going to get 0. So here are the points I'm using. These are, I'm going to plot this column with these points here. These are my y values. So I'm going to go over here and I'm going to plot them on my graph. So I have to mark off the lowest it goes is negative 2. Remember, because it follows that sine wave. And the highest it goes is positive 2, so I'll mark that off. And then let me plot those points. So I've got 0, 0, pi over 6, negative 2, pi over 3, 0, pi over 2, positive 2, and 2 pi over 3, 0. So I've got the maximum point here, I've got the x-intercept, and I've got the minimum point here. So this is one period. So I could copy and paste this in either direction if I wanted to extend it to the right or if I wanted to extend it to the left. So, and that was step 4. And we forgot to write that down. Let's fill in the blank here. Step 4, plot those points from step 3 and join them with a curve, having this should say join them with a curve having amplitude of the absolute value of a. The amplitude is half of the distance between the minimum and maximum. So here's the minimum, here's the maximum. The amplitude is half of this distance. This is 4 units, and the amplitude is half of that, so 2. If you want to look at the equation, you can see the amplitude. It is the absolute value of A, and A is -2, so taking the absolute value would be +2. And then, like I said, you could copy and paste this. Remember, it is the sine wave. So the sine wave repeats itself with each additional period. And so this is one complete cycle. So you copy and paste this each direction, or you figure out the, pi over 6 apart those intervals. And so that is how you graph the sine or cosine. Now, from the basic graph, you can also have shifts. And so let's talk about that. We can have translations. So you can have a vertical translation, meaning that the basic graph will shift up or down. So those look like this. And so if you have an equation where you have added positive or a negative number to the sine or the cosine, so it's added to the outside, then you're going to end up with a vertical translation. So let's make this statement. If k is greater than 0, meaning k is positive, then it will shift the sine or cosine wave up. So it'll be a vertical up. And if k is negative, then it will be a vertical shift down. You can also have a horizontal translation, and that looks like this. Horizontal means you shift it either left or right. And so it's either this. And so I'm adding or a positive. So it's going to say x minus a positive number or x minus a negative number. And again, it's either for the sine or cosine. And it's added to the argument of the sine or cosine function. So these are going to translate h units to the right if h is positive, or h units to the left if h is negative. So we're looking at this h itself. So you don't want to look at this. The minus sign is what's there. You need to look at the number itself. So in summary, if you have y equals k plus a times the sine of b times x minus h, the amplitude is equal to the absolute value of a. The period will be 2 pi over b. If there's a horizontal translation, it will be h, and a vertical translation will be k.